Hello everyone, we will wait for few more minutes and we will start. Hopefully more people will join by then. I hope that you're able to hear me and you're able to see my screen. So today we will discuss some questions that appeared in GATE TC 2022. That means last year GATE exam. Okay, mostly related with communication. So few of the questions that I have discussed previously in phase one, I think the initial two classes in the phase one, this GATE and BETL program. So I will discuss this question. I think one of you have there in that class, I guess. So this is a question related with information theory. Okay, from communication topic related with information theory. I hope you are able to see my screen. Okay, I think we can start. Do you hear me? Okay, thanks. Okay, so this is a question that appeared in last year GATE exam. So I think some of you have joined just now. So for them, I'm repeating again. So today I will show some questions that appeared in GATE 2022. That means last year GATE exam. Okay, mostly related with communication. And one last question that is a simple question from probability theory topic. Okay, so the first question is as follows. It's related with the entropy of a random variable. Okay, so the question is as follows. Let h of x denote the entropy of a discrete random variable x taking k possible distinct real values. Which of the following statements is or are necessarily true? This is a multiple choice question and you can see four options. Okay, so and we need to determine out of these four options which one is necessarily true. It's one or more options can be correct. Okay, so now first of all, what is h of x? H of x is defined. H of x is known as the entropy of the random variable x. X is a random variable. What does that mean? It is given that x is a discrete random variable. Okay, so that means x can take discrete values. say X takes values from this set, X1, X2, up to say X capital K. For example, if I have a die of 6 faces, okay, so if I throw that die, the outcome is a random variable, right? While throwing the die, the outcome can be 1, 2, 3, 4, 5, or 6, right? So that are the 6 values that the random variable can take. So now we will assume a general case X, which can take K values X1, X2 up to X capital K with probabilities. Okay, so X takes X1 with probability P1, X takes X2 with probability P2, X takes Xk with probability Pk. That means probability of X equal to X1 is equal to P1, probability of X equal to X2 equal to P2, etc. Probability of X equal to say Xk equal to Pk. Correct? So this vector P1, P2 up to Pk, this K length vector is known as the probability mass function or PMF of the random variable X. Okay, for such a random variable X, the entropy function h of X is defined as summation I equal to 1 to capital K. That means over all the values that the random variable can take, I equal to 1 to K, Pi log 1 by Pi. Okay, so this is the definition of the entropy function h of X equal to summation I equal to 1 to K, Pi log 1 by Pi. So notice that here the base of the logarithm is 2 in order to get h of X in bits. If I change the base of the logarithm, then the unit will differ. Okay, so if the base is say E, then the unit is known as nats. Okay, if the base of the logarithm is 10, then the unit of entropy is Hartleys. Hartleys. Okay, Hartleys. So for usually in communication theory or in information theory, we will stick to logarithm with base 2. Okay, so the unit of entropy is in bits. So this is the definition of the entropy function. Now you can notice one thing here. Here this h of X does not depend upon X1, X2 or X capital K. Instead of that, the entropy function h of X depends on the probabilities with which X takes values X1, X2 up to X capital K. Or in other words, h of X depends on the probability mass function or PMF of X. Right? For example, I have a random variable X which has a PMF 0.3, 0.4, 0.3. Okay, it can take 3 values, that random variable. I have another random variable Y which can also take 3 values, but with say so this X can take values say 1, 2, 3 with probabilities 0.3, 0.4, 0.3. I have another random variable Y which can take say some other values A, B, C with probabilities say 0.4, 0.3, 0.4. So basically these PMFs are coming as just a permutation of the first one, right? Or in other words, if I sort this probability mass function vector, then you will get the same vector. So here you can notice that h of X equal to h of Y. What is the reason? H of X or h of Y, that will depend upon only the probabilities, these PIs with which the values that it takes. Say here P1 is the values, P1 is the probability with which X takes value X1. So in this case, say 0.4 is the probability with which X takes value 2. Sorry, here there is a mistake. It has to be 0.3. Okay, so the sum has to be 1, right? The probabilities should sum up to 1. So basically this is a permutation. The second PMF is a permutation of the first one. Correct? So if I sort this vector, you will get 0.4, 0.3, 0.3. Correct? 0.4, 0.3, 0.3 you will get. So basically it has identical probability mass functions. Then the random variables will have the same entropy. Do you agree with that? Is it clear? Yeah. Any questions? So this is the only idea you have to solve this problem. So now come back to the problem. So yeah, before that, one more thing. Option A is trivially true, not trivially true, it's always true. This is a property of this entropy function. H of x will be always less than or equal to log k bits. Okay, that's a property. So I will again show that. I'm not going to prove that. That's a slightly tricky part because it needs some more tools that you may not be very familiar with. Something called KL divergence. Okay, I'm not complicating anyways. So this is a property, and there is one more interesting fact here. H of x equal to log k bits. So for which probability mass function this will happen? Can somebody tell? For a particular probability mass function, h of x will be equal to log k. Can somebody tell what is that probability mass function, or what is the distribution of the random variable? Okay, I will tell. For uniform distribution, say if x has uniform distribution, then h of x will be equal to, yeah, equiprobable. Exactly. All variables, all values will have the same probability. All realizations are having the same probability. For example, say in this case, 1 by k, 1 by k, 1 by k. So this will be the probability mass function. So for this probability mass function, this is uniform, right? So h of x will be equal to summation I equal to 1 to k. Pi means 1 by k, again log 1 by 1 by k, which is equal to summation I equal to 1 to k, 1 by k log k, which means log k, correct? So log k bits. So when all the values are equiprobable, then or if the random variable is uniformly distributed in the range set, then h of x will be equal to log k bits. Okay, and if there is some perturbation in the PMF, probability mass function, then the entropy will reduce. What I meant is that, say I have another random variable, say it has probability mass function 1 by k, say plus 1 epsilon, and 1 by k minus epsilon, and all the other values are 1 by k itself. Okay, the remaining k minus 2 possibilities will have, say it has probability 1 by k, then h of y will be less than h of x, or it is less than log k bits. Okay, this you can prove. It's a slightly tricky business, so I'm not going to do that here, but this fact you can take it as a property. H of x will be always less than or equal to log cardinality of this. So psi, or this is the set from which x takes values, then the cardinality of that. Okay, in this case k, capital K. So in general, h of x less than or equal to log cardinality of the set from which x takes values. Okay, so that means option A is correct. Now let us see different options. Okay, first let us see second option, option B. Option B says that h of x less than or equal to h of 2x. So option B says that h of x less than or equal to h of 2x. So we need to determine whether it is correct or incorrect. So I'm calling, or I'm defining a new random variable y such that y equal to 2x. Okay. Then say, as in the previous case, say x takes values from this set x1, x2 up to x capital K with probabilities p1, p2 up to p capital K. Then y takes values 2x1, 2x2 up to 2 times xk, right? So now what is the PMF of y? Is the PMF of y different from PMF of x, or are they same? Let us analyze that. Probability of, say, y equal to 2x1, that is nothing but probability of x equal to x1, right? So yeah, it is same, correct. Probability of x1 is nothing but p1. So probability of y equal to 2x2 is again probability of x equal to x2, correct, which is equal to p2. So up to pk you will get probability of y equal to 2 times xk is equal to probability of x equal to xk, which is equal to pk. So x and y are having the same probability mass function, or in other words, h of y, which is equal to h of 2x, because y equal to 2x, right? H of 2x equal to h of x. So what does that mean? Option B is also trivially correct. Trivially correct means it always holds with equality. Okay. So now coming to the third one, h of x less than or equal to h of x square. So that is option C. Now let us analyze whether that is correct or not. H of x less than or equal to h of x square. So what do you think? Is this correct or incorrect? Any guess? Okay, not same. Is this correct or incorrect? Option C, correct or incorrect? Incorrect. Okay. Anyway, let us see that. Let us take an example. Say x takes values -1 and 1 with probabilities half and half each. That means probability of x equal to -1 equal to probability of x equal to 1 equal to half. Now what is h of x? H of x equal to, so using the previous property, you can directly write it is equal to log 2, correct? What is the reason? It's uniformly distributed, right? That means 1 bit, or in other words you can compute. Okay, so I'm uh, not going to use that directly. Half log 1 by half plus half log 1 by half, that means 2 times half log 2, that means log 2 to the base 2, which means it's equal to 1 bit. Now what is y? If x takes value -1, y will be equal to, say I'm defining y to be equal to x square. Okay, y equal to x square. Let us assume y is a new random variable which is equal to x square. Then y can take value +1 if x equal to +1. Again, y will take value +1 if x equal to -1 as well, right? Then y will always take value 1, and probability of y equal to 1 is also 1. Irrespective of what the value x takes, x can be either +1 or -1. Irrespective of that, y will be always +1. And probability of y equal to 1 is thus 1. Correct? Now, what is h of y or h of x square? H of x square equal to h of y, because y equal to x square, right? Which is equal to 1 times log 1 by 1. Log 1 is 0. So what does that mean? H of x less than or equal to h of x square, which this is the given statement, correct? This is incorrect. This is not true. That means option C is not correct. Now we have one more option to see, h of x less than or equal to h of 2 power x, whether this is true or not. That is the final question that is remaining. Correct? Now, before answering that question, let us see the option B and the option C. So, what has really happened there? What is the difference between option B and option C? So, here I have defined y equal to x square. Here I have defined y equal to 2x. Correct? In option B, y equal to 2x, and here y equal to x square. Or in other words, I have defined a new random variable which is a function of the other random variable. Correct? But in one case, h of x was turned out to be equal to h of y. But in the next case, that was not the case. H of y was different from h of x, and in fact, h of y was strictly less than h of x. Correct? In this case, h of x square was 0, but h of x was 1. So this was the case in option C. So what has really happened? Why is it happened? Can somebody tell that answer? Any idea? Okay, I will tell that. So here, if you see in option B, when x takes value x1, y takes value 2x1. When x takes value x2, y takes value 2x2. Correct? That means a one particular value that x takes will map to a value that y takes. But at the same time, a different value that x takes, that means x2, will map to a completely different value. Correct? That y takes. 2x1 cannot be equal to 2x2 unless x1 equal to x2. Do you agree with that? But in the next option, or in option C, what happened? Say x could take value -1 and +1, but both those values map to the same value that y can take. Agree? Do you agree with that? Or in other words, the function that mapped from x to y was 1 to 1 in the first case, but in the second case, the function that mapped x to y was not 1 to 1, right? Y equal to 2x is a 1 to 1 function, but at the same time, y equal to x square is not 1 to 1 function, not 1 function. If x takes values -1 and +1, agree? It depends upon the domain of x as well. If x can take values, say, if x takes values from the set 1, 2, then y equal to x square is a 1 to 1 function. But when x takes some other values, -1 and the +1, then y equal to x square is not a 1 to 1 function. Or in other words, in general, y equal to x square is not a 1 to 1 function if x takes values from the real line. Agree? So now we have the important property that is actually you can observe from the previous two examples or previous two options. H of x will be equal to h of f of x if function f is 1 to 1. H of x will be strictly greater than h of f of x if f is not 1 to 1. Correct? Do you agree with this? So this is happened in the first case, option B. This is happened in second case, that means option C, in which f of x was not 1 to 1. But in option B, f of x was turned out to be 1 to 1. So h of x was equal to h of f of x. Now the only remaining question is y equal to 2 power x. Is this 1 to 1? Is this 1 to 1 or not? If it is 1 to 1, then h of x will be equal to h of 2 power x. If not, h of x will be strictly greater than h of 2 power x, and option D will be incorrect. It is 1 to 1. Great. That's correct. So that you can easily observe from, say, this is x and this is 2 power x. Then this is the graph of 2 power x. Correct. So you can see this is a 1 to 1 function. So in the previous case, x square was having a shape like this. Correct. So two values, say here and here, this will map to the same image by the function x square. But this is 2 power x. Here you can clearly see. So this is a 1 to 1 function. So f of t equal to 2 power t is a 1 to 1 function. Therefore, h of x or h of 2 power x equal to h of x. Right? What does that mean? That means that option D is also correct. Any doubts? Any questions? If you have some questions, you can raise now, or else after like all the questions also you can come. We can come back and discuss this question again. So far, so good. Let me proceed. Okay. So now we will see another question that appeared in GATE 2022. Okay. So it's a fairly straightforward question. Doesn't involve too much of calculations, but you have to have that um, idea of coding and modulation. Okay. So the question is as follows. A symbol stream contains alternate QPSK and 16 QAM symbols. If symbols from this stream are transmitted at the rate of 1 mega symbols per second, the raw data rate or the uncoded data rate is. So it's a numerical answer type question, and we need to round off the answer to 1 decimal place. Okay, and also the unit is given as megabits per second. So the question is very straightforward. It's a stream of data is being transmitted over a channel. Okay, and the data rate is given as 1 mega symbols per second. Symbol rate. Symbol rate is equal to 1 mega symbols per second. Correct? And you can see that if symbols from this stream are transmitted at the rate of 1 mega symbols per second, the raw data rate or a symbol stream contains alternate QPSK. Oh, okay, this is the portion you have to look into. Alternate QPSK and 16 QAM symbols. That means out of the 1 mega symbols that is being transmitted in 1 second, half mega symbols will be from QPSK and the remaining half symbols will be from 16 QAM. Agree? Number of QPSK symbols transmitted per second is equal to half into 10 power 6 or half m mega symbols. Correct? So I'll write half into 10 power 6. 10 power 6 means mega. Correct? So now number of 16 QAM symbols transmitted per second equal to half into 10 power 6, 16 QAM symbols. Up to this, any confusion or any questions? Okay, let me proceed. Okay, now the question is, one QPSK symbol corresponds to how many bits? Or one QPSK symbol carries how many bits of information or how many bits of data? Okay, first of all, what is QPSK constellation? So this is a QPSK constellation, right? So I have my data symbols at these points. So there will be how many symbols in a QPSK constellation? There will be four symbols, correct? QPSK means quadrature phase shift keying, QPSK. So this is one QPSK symbol carries how many bits of information then? Can somebody tell? Or one symbol corresponds to how many bits? Exactly, 2 bits. What is the reason? So there are four symbols. So I can represent four symbols using 2 bits: 0, 0, 0, 1, 1, 0, 1, 1. These are the two length binary strings, right? Two length binary vectors. So there are four possibilities. Or in other words, if I have m symbols, I need to have log m to the base 2 bits to represent them. Do you agree with this? I have, say, I am using an 8 PSK instead of QPSK. QPSK means 4 PSK. Instead of that, I am using an 8 PSK. How does 8 PSK look like? 8 PSK will have 8 PSK will be having 8 8. This is the constellation diagram of 8 PSK. It has 8 symbols, and each symbol corresponds to 3 bits. 3 means log 8 to the base 2. 8 means 2 cube, right? So this is equal to 3 bits. Agree? Now, then what about 16 QAM? So there will be 16 signal points in the 16 QAM constellation diagram. I can draw that if you need. That will look like some. So that will look like this: 16 points. QAM means quadrature amplitude modulation. So 16 points, 16 symbols basically. So one symbol corresponds to how many bits then? Log 16 to the base 2, right? What is that? Log 16 is how much? It's very straightforward, no? So log, that means 4 bits. So if you want, I can write all the points, okay? So 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. So now it's already 8. So you can have the same string with replacing the MSB 0 to 1. I will write 1, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. Okay, now you have 16, right? So say this I will use to represent this. The second one I will use to represent this. So I can map these 16 bit patterns to these 16 symbols, which means one symbol will correspond to 4 bits. So now how many symbols you have per second? So you have half into 10 power 6 QPSK symbols. That means this will correspond to, each symbol will correspond to 2 bits. So it will correspond to 2 into half, which is equal to 1 into 10 power 6. 1 into 10 power 6 bits. correct? Now, in the case of 16 QAM, each symbol corresponds to 4 bits. So half into 10 power 6 symbols will correspond to 4 into half, which is equal to 2. 2 into 10 power 6 bits. So now the total number of bits transmitted per second is 3 into 10 power 6 bits. Agree? Which means 3 megabits per second is being transmitted. So this is the uncoded data rate or the raw data rate. Any questions? So the answer to the question is 3 megabits per second. Any questions? Any doubts? Is it clear? Okay. Can we go to the next question? Okay, thanks. So this is again a question that appeared in 2022 GATE exam. This is a question related with coding theory. Okay, error control coding. So the question is as follows. Consider communication over a memoryless binary symmetric channel using a 7-4 Hamming code. Each transmitted bit is received correctly with probability 1 minus epsilon and flipped with probability epsilon. For each code word transmission, the receiver performs minimum Hamming distance decoding and correctly decodes the message bits if and only if the channel introduces at most 1 bit error. Okay, you have to be very careful here. For epsilon equal to 0.1, the probability that a transmitted code word is decoded correctly is. This is again a numerical answer type question. Okay. So now the communication is over a binary symmetric channel. I think all of you were there when we discussed about binary symmetric channel in the last class. If you are having some question, you can ask now. Okay. So a binary symmetric channel model is as follows. So the input can be either 0 or 1. Output can also be either 0 or 1. If the channel input is 0, then the output will be 0 with probability 1 minus epsilon, and the bit 0 will be flipped to 1 with probability epsilon. Similarly, if the channel input or the transmitted bit is 1, then the received bit will be 1 with probability 1 minus epsilon, and the bit 1 will be flipped to 0. An error will happen with probability epsilon. So this probability epsilon is known as the bit flipping probability or error probability, or so various names are there. Bit flipping probability is the most common name. Okay, so and yeah, this is the binary symmetric channel model. So now the channel that we are considering is binary symmetric channel. So over this binary symmetric channel, the the communication is using 7-4 Hamming code. Okay. So what is the speciality of this code? So don't worry about Hamming code. The property that we need to use is already given in the question. This code can correct at most 1 bit error. Okay. So first of all, what does this 7-4 Hamming code do? What does it do? So this 4 corresponds to the message vector length. Message vector length, or in other words, we will use the notation k, which is equal to 4, and code word length, which is usually denoted with lowercase n, equal to 7. Okay. First of all, why are we doing this coding? Any answers? Coding is done for reducing the error probability or probability of error. Okay. So I have to transmit 4 bits. But initially I will convert this 4 bits to 7 bits using Hamming code. Okay. And instead of transmitting 4 bits directly, I will transmit the code word which is of length 7 over the binary symmetric channel. Okay. That means I will transmit 1 bit at a time, and the bit will be received correctly at the output of the channel with probability 1 minus epsilon. It will be flipped with probability epsilon. Okay. So there will be 7 transmissions because code word is of length 7. Okay. I think I should explain why is this coding used, or this error control coding is used, or how is it reduce the probability of error. We will simply take an example. Okay. So I have to transmit either 0 or 1 over the binary symmetric channel. Okay. But there is a probability of error which is equal to epsilon, correct? Say epsilon equal to some value, 0.1 as given in the question. Assume that, okay, epsilon equal to 0.1. Then the probability of bit error is nothing but 0.1, right? If I transmit, say I need to communicate 0 to the receiver, then the transmitter transmits 0. But there is a probability of bit flipping which is equal to 0.1. But now I'm doing a simple trick. What am I doing? Instead of sending 0 once, I will transmit 0 thrice. That means 3 times if I want to communicate 0. If I want to communicate 1, I will transmit 1, 1, 1. That means I will transmit 1 3 times over the channel. Okay. So if I transmit 0, 0, 0, so what are the possible, say, forget about 1, 1, 1 for the time being. Okay. If I transmit 0, 0, 0 3 times over the channel, what are the possible outputs, or what are the possible received binary vectors? So is it possible to receive 1, 1, 1? That means an error in the first case. That means error in the first transmission, error in the second transmission, error in the third transmission. That is possible, right? Because in every transmission, there is a probability of error which is equal to 0.1. So we will start with a case where there are no errors. If there are no errors, I will receive, or the output will be equal to 0, 0, 0. Correct? The first time. So this is the first, second, third transmissions, first, second, and third received values. Okay. So if there are no errors, then 0, 0, 0 will be received. If there is one error in the first instant, then 0, 0, 1 will be received. And there are no errors in the second and third transmissions. And this is one other possibility. This is one other possibility. This is one other possibility. In this possibility, that means an error happened in the first transmission, no error has happened in the second transmission, and there is an error in the third transmission. Then 1, 0, 1 will be received, right? And this is also possible. 1, 1, 0 and 1, 1, 1. Which one did I miss? I missed something, right? Yeah, I missed 0, 1, 1. So this is also possible. So there are 8 possibilities, right? So if I transmit 0 3 times, out of this 8, one possibility will happen, correct? According to the error that is introduced by the channel. Do you agree with that? Now, what is the policy adopted by the receiver? Now there are 3 received bits, right? How will the receiver will determine which one is the transmitted one? So it will do majority logic. That means out of the 3, which one is occurring, 2 or more, that will be the decoded bit. Okay, in this case I will denote that with x hat. Okay, if I am transmitting x which is equal to 0, in this case x hat is the received decoded bit. Okay, receiver decoded bit. So in this case the receiver will decode in favor of 0. In this case receiver will decode again in favor of 0. In this case again 0. In this case there are 2 ones. So basically 2 error has happened. Then the receiver will incorrectly decode to 1. So here again 0. Here 1, here 1, here all the 3 bits have gone wrong, then definitely the receiver will tell that receiver will also make a error in decision making. Agree? So now you will wonder again, 4 possibilities are zeros and 4 possibilities are 1. What is the advantage? Now, if you see that, when will an error happen? An error happen when the received bits or the received vectors are either this, correct? Either this or this. That means y equal to 0, 1, 1, y equal to 1, 0, 1, 1, 1, 0, or 1, 1, 1. Agree? What is the probability of y being equal to 0, 1, 1? That means there are 2 errors. In the first transmission, no error. Sorry, in the first transmission, there is an error. In the second transmission, there is an error. And there is no error in the third transmission. So epsilon into last one, no error. That means that has a probability of 1 minus epsilon. So which is equal to epsilon square into 1 minus epsilon. Now probability of y equal to 1, 0, 1 is also epsilon into 1 minus epsilon. That means error, no error, error. Again epsilon square into 1 minus epsilon. Now probability of y equal to 1, 1, 0 is no error, error, error. That means epsilon square into 1 minus epsilon. Probability of y equal to 1, 1, 1 is nothing but epsilon into epsilon into epsilon. All the bits have gone wrong, which has a probability epsilon into epsilon into epsilon. All the channel uses are assumed to be independent. Okay, that is the binary symmetric channel model, which is equal to epsilon cube. Now the total probability of error is equal to epsilon cube into 3 times epsilon square into 1 minus epsilon. So I'm adding all these 4 cases. So which is equal to 0.1 whole cube plus 3 times 0.1 whole square into 0.9. Agree? Which is equal to 0.001 plus 2.7 into 0.01. Agree? Which is equal to 0.001 plus 0.027, which is equal to 0.037, which is very much less compared to the previous probability of error, which is equal to 0.1. If I'm sending only ones, then the error probability was 0.1. But now the error probability has significantly reduced to 0.037. Do you agree with this? Any questions, any doubts? This is the main idea of error control coding. Everybody agree with this? Any questions? Yeah, great. So now we are achieving better, or we are gaining in probability of error. Now we could reduce the probability of error. What has we sacrificed, or where are we like losing something? We are losing in what? Bandwidth, right? Initially I was transmitting only once. Now I have to transmit the same thing 3 times. That means I am wasting power or maybe bandwidth. Agree? But we could reduce the probability of error. So this is a trade-off between probability of error and power or bandwidth. Okay. So this power or bandwidth, that will depend upon the transmission scheme that we are using. In general, it is bandwidth. Okay. Now that is the case. Now come back to the given code. This is known as the repetition code. Okay. So I'm repeating the same thing 3 times or 5 times or 7 times. So if I repeat 7 times, my probability of error will reduce drastically. But the thing is that I am repeating the same things 7 times. That means my data rate is coming down by a factor 7. Basically, I am communicating only one out of the 7 channel users. I am transmitting only 1 bit. Correct? So my data rate has come down by a factor 1 by 7. So now come back to the question. Okay. In the question, this is again the same way as we calculated this probability of error. In this case, the message vector has length 4. In my example, it was 1. Now code word length has 7. In our example, it was 3. Okay. So suppose I have some code word which has length, say I will assume that my something 0011. This is the 4 length message vector. This will be mapped to a 7 length vector. It can be anything. What I am writing need not be correct. Okay. But say this is this. This is a 7 length code word. This is what we are transmitting over the channel. The 7-bit code word will be transmitted over the binary symmetric channel. And if there is 1-bit error, that can be corrected by the code. That means if there are more than 2 errors out of the 7 transmissions, if 2 or more errors happen, then that will be go in error. In this our example, so if 2 errors, here 2 errors happen, here also 2 error, here also 2 error, here 3 errors, right? So this code can also correct 1 error. 2 or more number of errors will lead to a decoding error, as in this case. So now I am transmitting 7 bits. The question is to find, not to find the probability of error, it is to find the probability of correctly decoding. Okay, so what is the probability of correctly decoding? Probability of correctly decoding means probability of no error, that is one case, plus probability of do you agree? That is what is given in the question. See, for each code word transmission, the receiver performs some decoding, minimum Hamming distance decoding, and correctly decodes the message bits if and only if the channel introduces at most 1-bit error. Agree? So everybody agree with this? Probability of correctly decoding means probability of no error plus probability of 1-bit error. If there is 1-bit error, then the code will correct that. There will be no decoding error in that case. Is it fine? Yeah, great. Yeah. So now, what is the probability of no error? That means all the bits are correctly decoded. So what is the probability of not correctly decoded? All the bits are correctly received at the binary symmetric channel output. So receiving 1 bit correctly at the output of the binary symmetric channel has a probability 1 minus epsilon. So similarly, 7 bits has to be correctly received at the receiver output, which has a probability 1 minus epsilon power 7. Agree? 1 minus epsilon first bit, 1 minus epsilon second bit, 1 minus epsilon, 1 minus epsilon, 1 minus epsilon 7 times. So the probability of no error is 1 minus epsilon power 7. Okay. So now what is the probability of 1-bit error? So here you can see 1-bit error can happen in one way, 2-way, 3-way. Correct? In this example. Now the code word is of length 7. That means the error can happen for this bit, which has a probability epsilon, and all the remaining 6 bits are correctly received, 1 minus epsilon power 6. But this error can happen to this bit, second bit as well, or to third bit, or to fourth bit, or to fifth bit, or to sixth bit, or to seventh bit. That means there are 7 such possibilities. So total probability of 1-bit error is 7 times epsilon times 1 minus epsilon power 6. Just in the previous case, we got 3 into epsilon square into 1 minus epsilon, right? That is probability of 2-bit errors. Now this is the probability of 1-bit error. Do everybody agree with this? Is it okay or not okay? Okay, good. What about others? If you have some questions, you can ask now. If not, I will just substitute the value of epsilon and I will get the answer. So epsilon is given to be 0.1, right? Which means 0.9 power 7 plus 7 times 0.1 into 0.9 power 6. So which means that which is equal to, say, if I take 0.9 power 6 outside, 0.9 plus 0.7, which is equal to 1.6 into 0.9 power 6, You can use a calculator and you will get an answer 0.8503. So the answer to the question is 0.8503, and it is asked to round off the answer to 2 decimal places. That means the answer to the question is 0.85. The probability of correctly decoding is 0.85. Any questions? Is it okay? Okay. Yeah. Yes. We have one more question that is very simple question. This has appeared in last year GATE exam. So this is high school level maths question. But anyway, I'll do this. I have 4 more minutes. So this is one of the questions that came in the last year exam related with probability theory. That means from engineering maths. So some questions will be really easy like this. Okay. So you should not miss this. So the question is as follows. The bar graph shows the frequency of the number of wickets taken in a match by a bowler in her career. For example, in 17 of her matches, the bowler has taken 5 wickets each. The median number of wickets taken by the bowler in a match is. So a bar graph is given. We need to find the median of the numbers. Okay, there are 3 types of averages. You will be knowing all these things: mean, median, and mode. Right? Mean means you just need to take the sum of all the observations and divide by the number of observations. Then mode means the most frequently happening observation is the mode. That means if I have these numbers 1, 2, 1, 3, 5, 6, 1, 2. What is the mode of these numbers? Mode is nothing but 1, because 1 is repeating 3 times. The frequency of 1 is 3. 2 is appearing 2 times. 3, 5, 6 are appearing once. So which is the most frequently appearing number? Which is 1. So the mode is 1. Okay. So now from the given bar graph, you need to find the median. How do you find the median? Median means you have to list the observations in the ascending order. Say if there are n observations, then the median is the observation at the n plus 1 by second position. If n is odd, if n is even, then median is nothing but what? N by 2 why is it not working? Sorry. Yeah, n by 2 and n by 2 plus 1 positions. The mean of n by 2 observation and n by 2 plus first observation. Okay. For example, if my observations are 1, 2, I'm writing in the ascending order itself: 1, 2, 3, 5, 7. Then what is the median? Median is nothing but there are 5 observations. Then 5 is an odd number, right? 5 plus 1 by 2, which is equal to 3. The third observation, which is equal to 3. If there are, say, 6 observations, 1, 2, 3, 5, 6, 8. I am writing in the ascending order itself. If it is not in the ascending order, you have to make it in the ascending order. Okay. So now n by 2 means third observation, and n by 2 plus 1 is the fourth observation, which is equal to 3 and 5. So you have to take the average of 3 and 5. Average means the mean. 3 plus 5 by 2 equal to 4. So in this case, 4 is the median. Okay. So now come back to the question. So now the observation is given in the form of a bar graph. So can somebody tell the answer? So you can sum up all these things. So basically, the observations are the number of wickets taken in a match, right? So the bowler has taken 0 wickets, no wickets in 5 matches. The bowler has taken 1 wicket in 7 matches. The bowler has taken 2 wickets per match in 8 matches. In 25 matches, the bowler has taken 3 wickets. In 20 matches, the bowler has taken 4 wickets. In 17 matches, the bowler has taken 5 wickets, and so on and so forth. Okay. Now, how many matches are there, first of all, that you can compute by just adding this? 5 plus 7, 12 plus 8, 20, 20 plus 25 is 45, 45 plus 20 is 65, 65 plus 17 is 82, 82 plus 8 is 90, 90 plus 4, 94, 97, 99, 100. So there are 100 observations, 100 observations. Okay. So 100 observation means median is equal to 50th observation plus 51st observation divided by 2. So this is the median because 100 is an even number. So what is the 50th observation and 51st observation? So you can just sum. So here five observations are over, 12 are over, 20 are over, 5 plus 7 plus 8, 20. So by this, by 25, that means what is happening here? 0 will happen 5 times, 0, 0, 0. Then 1 will happen 7 times. 1, 1, 1, 1, 1, 1, 1. So 2 will come 8 times, 2, 2, 2, 2. It goes like that. Okay. So you need to find the 50th observation. So by 3, 45 will be over. And up to from 46 to 65, it will be 4. So 50th observation and 51st observation, both are nothing but 4. So the median is nothing but 4 plus 4 by 2, which is equal to 4. So the answer to the question is 4. Any questions? So now the time is 7 o'clock. So if you have some questions, you can ask. Otherwise, we will wind up. So for the next 2 weeks, we will discuss questions related with engineering maths. Okay. Linear algebra and probability theory. Okay. If you don't have any questions, we can wind up the session. See you in the next Tuesday. See you next Tuesday. Okay. Thank you.